皆さんようこそおいでくださいました。イエイ。あまり久しぶりじゃないですよね。
そうですね。一緒に沖縄で仕事してた。
あ、それですか。そうなんですね。OWASPジャパンの名をアジアパシフィックに知らしめるべく、先週までですね、マレーシアの政府の人たちにセキュリティを教えるという、そういうこれは仕事でそうしてまして、でそこに上野さんがも参加していただいてありがとうございました。大変お疲れ様でした。
楽しかったですよ。
そうですね。
沖縄が。
そしてですね、沖縄がでも寒い沖縄って本当にありがたいですね。
彼らちょっと残念がってます。
そうですね。マレーシアが来てさらに寒い沖縄のところに来た。はい。OWASPジャパンのステッカーを全員初日に配布したら、漏れなく全員タブレットとパソコンに貼ってくれましてですね。多分OWASPマレーシアがこれまで頑張ってきたことを上回るプロモーション力。
一応OWASPマレーシアっていうのはちゃんと
あるんですよね。
いつもハックインザボックスっていうイベント行くとOWASPマレーシアのブースが出てるんで、
はい、頑張ってますよね。はいはい。でも彼らOWASP全然知らなかったです。
知らなかったですね。
知らなかったですね。はい、そういうプロモーション活動を体を張ってやっている我々OWASPジャパンリーダーでございます。はい。はい、皆さんよろしくお願いします。皆さんお気づきの通りですね、今日のプログラムはこの司会進行も含めて全て英語で提供されております。おお、裏切った。今みんな笑うところだった。
かぶせてきます。
はい、というわけでですね、本当に英語でやっても大丈夫だったんですけれども、最初にですね、今日の会場提供の、ちょっとスライドをめくっていきます。会場提供のですね、藤井ゼロックスさん、どうもありがとうございます。ちょっとこの会場の案内を、していただくことも含めましてですね、我々が誇るですね、OWASPジャパンの運営チームので頑張ってくださっている中野あたりさんをご紹介したいと思います。はい、いいですよ、そのまま。事前にスライドをマージするという努力すらしていないというこの我々のこのアドホックな感覚をですね、隅々まで味わっていただけるといいと思うんですが、はい、では中野あたりさんです。どうぞ。
初注意です。初注意。中野あたりですとか言って。中野あたりです。いや、このビル、耐震構造になってますので、地震があっても慌てて逃げないでください。それで、津波が来ても大丈夫なぐらいの高さがありますので、ここに行ってくださいというところで、帰りなんですけれども、8時を過ぎると、今入ってきたゲートが閉まってしまうんですね。自動ドアで入ってきたところだと思うんですけども、そこは閉まってしまうので、一回受付のところまで行って、そちらから、案内しますので、裏口の方から帰っていただくことになります。非常口ですね。そうですね。非常口の方で警備員さんがいるので、そちらの方から帰ってもらいます。で、今首から下げているカードは、ちょうどフラッパーゲートのところでかざしてもらって出て、その後に回収しますので、そこに、ちゃんと返してください。これがなくなると僕がこっぴどく怒られることになるので持ち帰ったりしないようにお願いします。これで今会場ホール AB なんですけれども、そちらトイレはこちらの出て突き当たってから、裏側ぐるっと回るといったところになります。あとは普通にですね、エレベーター途中退出する方はこちらの方から帰られると。で後ろの方に受付のスタッフジャンパー来たメンバーがいますので、途中退出の方はこちらの方に一声かけていただいて、一緒にゲートまで行ってもらって、でカードを返して退出していただくということになります。で注意なんですけど、ここ8時を過ぎるとここも閉じてしまって、こっち側から入ってくることはできません。ですので1回退出してセブンイレブンの方に行きたいという方は、その方もスタッフの方に声をかけてください。一緒に入らないといけません。ここだけ注意をお願いします。
ちょっとドラちゃんにマイクを渡して。
ドラちゃん今の英語でお願いしますね。
ちょっと事前に
スピードランニングで。
So for those of you, most of you probably only speak English, so I'm going to translate the Japanese. If you want to leave permanently, please submit your card. the one hanging around your neck. Why? Because the gate from which we came in is going to be locked. But if you want to stay for the end of this session, please wait for the instructions at the end because we're going to have to go out the back way. And when we're leaving, we all have to return our cards. So,
そんな感じですよ。ありがとうございます。はい、ありがとうございます。でですね、普段我々3ヶ月に一度チャプターミーティングをやっているわけなんですが、今回初めて、OWASP ナイトに来られたという方はどれぐらいいらっしゃいますでしょうか。いやー、
相変わらずの
安定のですね、そうですね、よくこのなんていうのか、オープン後3時間ぐらいで満タンになってしまう OWASP ナイトに滑り込まれましたね。いや、本当ね、毎回素晴らしいですよね。
横浜初開催ですね。
そうですね。今回横浜初開催だから来れたっていう方どれぐらいいらっしゃいますか。おお、なるほどなるほど、ありがとうございます。だから一部嘘があったような気がしますけれども、でも、ね、そういう方もいらっしゃって嬉しいですね。はい、どうもありがとうございます。こういう感じでぐだぐだやってますけれども、やる内容は真剣ですので、ぜひ楽しんでいただければと思います。ここまで日本語でやってきたわけなんですが、今回はYes, this time, so ladies and gentlemen, we can welcome Jerry Hoff. Yay! Does anybody know Jerry Hoff?
私も
いや、今多分そのイングリッシュライクな英語でも日本語でもないような言葉で聞いたからみんなわからなかったと思うんですけど、ジェリー・ホフさん知ってる人、あげるとこあげるとこあげるとこほらみんな知ってるで、はい、ちなみにこの画像ですね、すごくこう、ね、ものすごくこう何か発表してますっていう感じに、見えますよね。でも不思議と隣の人も同じ方向をなんとなくモニターの方を見ているような、ね、だんだん分かってきましたが、本当のロックスターの意味が。これはアップセック APAC の時に撮影されたものなんですが、はい、カラオケ
サザン
はい、というようなことで、本日はですね、約90分にわたる熱唱を聞かせていただけるという素晴らしい
ステージ、
はい、ただし本当に通訳入れませんので、ぜひ楽しんでいただければと思います。ただ、少しツイートかドアキーパーでお送りしましたけれども、ムービーとかそういうコーディングとかそのものも出てきますので、おそらくほとんどは分かるんじゃないかと言っていましたので、それもうちょっと難しくしてもらえませんかと実はお願いしまして、で少しアドバンスな感じで、もうなんかもう多分説明してくれると思うんですけれども、当初やろうと思っていたことがちょっとアドバンスな感じに変わりましたので、ぜひ楽しんでいただければと思います。一応予定は90分ぐらいで、プレゼンテーションを終えて、で、おそらく9時までには終了できるんじゃないかなという見込みで進めていきたいと思っておりますので、皆さんそれで大丈夫でしょうか。はい、ではよろしくお願いします。では、皆さん拍手でお迎えください。ジェリー・ホース。
大丈夫？あ、よかったね。あ、ここで。テスト。OK。このレクチャーは 100% 英語で大丈夫ですか？ OK。でも99% けど、初めてで自己紹介日本語でやりてもいいですか？大丈夫ですか？はい、ありがとうございます。皆さん、本日はお集まりいただきありがとうございます。私はジェリー・ホフと申します。アメリカの出身、フロリダですが、 最近は仕事のために世界中を飛び回っています。日本の来るのは今回で7回目です。私の会社はホワイトハットセキュリティというモバイルとウェブサイトのセキュリティの会社です。そう、これはフロリダです。すみません。ワシントン大学の大学院でコンピュータプログラミングを学びました。その後仕事はリーマンブラザーズでプログラミングしました。モーガンスタンレー香港でコンピュータコンサルティングをしました。もう独立して銀行と政府いろいろの銀行でコンサルティングをしてきました。実は仕事以外、私の趣味もセキュリティです。OWASP のために YouTube で OWASP Top 10のビデオシリーズを作りました。これは30万ビューを記録しました。ありがとう。その以外もよくウェブでセキュリティのブートキャンプの無料のデベロッパートレーニングをする。よく1500人ぐらいアテンドする毎回。このプレゼンテーションはブートキャンプです。今ごめんなさいけど今英語にスイッチをする。So this boot camp is the same boot camp that I do on the web, which is a developer-centric training boot camp where we go through and look at how to build a web application, we look at how the attackers attack that application, and then we talk about defending the application. 大丈夫ですか？ Okay, so ありがとうございます。今から英語ばかりで。All right, so let's talk very quickly about security. I don't know how it is in Japan, but in America, there are hacking incidences all the time. So literally every single day when you look in the news, some major bank or some major organization has been hacked. So recently we have a Mexican fast food restaurant that was hacked and lost many credit cards, or their Twitter account was hacked, I'm sorry. Insurance companies were hacked, 80 million people's records were accessed. You have people stealing tax identification numbers and tax refund numbers from the web. The American government in Utah receives 300 million attacks every single day. So obviously, every single day. So this is obviously a major global problem. And this is kind of like ちょっと親父ギャグ. So in English, hacked is also to take a knife and kill somebody. So this man was hacked to death because he was singing at karaoke. But it's kind of a joke. So it works in English. But anyway, so security is not optional. So in this presentation, we're going to be looking at ASP.NET. So Microsoft's ASP.NET platform. We'll be looking at the security. Now, if you think, well, I don't know anything about ASP.NET, the same principles we will be talking about also apply in Java and PHP. Yeah. So far, so good? Make sense? みんなは 100% わかるの？わかりますか？ Okay, hopefully. All right. もうゆっくり話しても大丈夫ですか？どっちでもいいですか？ All right. Sorry, I get very hyper sometimes. I get kind of energetic. So if I start speaking fast, just tell me to slow down. So you can see here that although this is a major problem, from the statistics, most people still don't care that much about security. So when you look at how many people are Googling for ASP.NET security, PHP security, Ruby security, Python security, it's very low. The one difference is Java security, right? That's really high, but that probably is because of Java applets and Java desktop, not necessarily Java web applications. Okay, so in other words, the interest level in web security, which is what we're going to be discussing today, is still relatively low, unfortunately. Now, some frameworks like Microsoft's .NET MVC does come with many security features turned on by default. In other words, if you're a developer and you grab a framework, you want to use a framework like Spring, .NET MVC, like Ruby on Rails, like Django, a lot of the times these frameworks are starting to build security in, which is a really good thing. But the problem is if you believe that the framework will cover 100% of the security. That is the problem. If you think, oh, I'm using Microsoft.NET MVC, I'm sure it's safe, that's not necessarily true. In other words, the framework will give you some security. So for example, you can see that there's cross-site scripting encoders built into .NET. There is anti-CSRF built into .NET, and the same thing applies for many modern frameworks, right? Ruby on Rails has a lot of these things built into it as well, and so does Django. What we're going to be looking at today are the gaps. So the places where the security falls down, all right? First thing I hope everybody does is everyone should be aware that every time you use any third-party code, you should do a check to see what are the known vulnerabilities for that framework or for that library. Okay? So for example, hopefully everybody is familiar with MITRE.org, where you can go. There's many, many resources on the web for this kind of thing, but MITRE.org gives you a listing of known vulnerabilities. So when I went for .NET, you can see that there's something like 6 or 8 vulnerabilities in the .NET framework itself that were reported last year alone. So understanding the version that you're using, understanding the library is extremely important, and it's a step that most people skip. Okay? Now, where does a developer go if they want to learn secure training, right? So where does a developer go to learn about security? Most developers turn to the OWASP Top 10. The OWASP Top 10 is a free document that you can download from owasp.org, and it lists out essentially 10 very common vulnerabilities in web applications. So if you're just starting security, I think this is a good document to read. However, I'm not a huge fan, I'm not a big fan of this document because it's too simple. It's too basic. And it doesn't really change depending on which language you're using, which framework you're using, or what kind of company that you're running. And the reason why I have this problem with the OWASP Top 10 is in my job, I get to visit and do consulting every year for hundreds of companies. So I fly around and I talk to security teams at the largest banks in the world, the largest defense contractors. And when I ask them what are they worried about or what is the basis of their security program, they tell me the OWASP Top 10, which hurts my heart, right? Because it's too basic, it's too simple, and it doesn't take into account what we call the security posture or the risk tolerance of the company. So I'm a big fan of this. If you have not downloaded this, I would recommend that you download this immediately. This is the OWASP ASVS. And there's a very long URL here, but if you just Google OWASP ASVS, it will come right up. The OWASP ASVS is a document that goes through 180 potential vulnerabilities. So they list out 180 things to look for, and these are the different categories in which those 180 points exist. And obviously, if you're doing mobile, then you would take care of mobile. If you were looking at malicious controls, business logic, so you can really customize this document to meet the security posture of your organization. Now, in this very condensed boot camp, we're going to be getting into code. the most important thing to remember, if you're build any application, mobile, web, thick client, etc., is that you can never trust any input. So if you're building a web application or if you're building a mobile application, you have to realize that every single piece of data that's coming at your application from the outside world has to be considered untrusted. Make sense? Untrusted. You cannot trust any external data. 大丈夫 ?OK。一番大切なポイントです。ずっとの外からのデータを信じないしなければならないんです。All right. So obviously I shouldn't try Japanese. I'm very low level, but okay. But this in a web application, you can see where all the untrusted data comes from. Cookie header names, header values, cookies, method verbs. What is a method verb? Get, post, things like that. Exactly. So there are even attacks where the method verb is altered, which then can have a security implication on the web application. Parameter names and parameter values, parameter existence. So I have successfully hacked into web applications by removing parameters. The application doesn't know what to do, it throws an exception, and I'm able to access something I was not supposed to access. Repetition of parameter. So believe it or not, sometimes when you repeat the same parameter twice, like name equals Jerry, ampersand, name equals, Tom, then something like that can cause a problem within the application, where the first instance of the variable is validated, but then the second one is used. So you would never expect this normally, but these are the bizarre behaviors of web and mobile applications. There's also legitimacy of requests. If your web application receives a request with a valid cookie, that doesn't mean it's valid. So there are ways, if you come to let's say in your web browser, you come to a website that I own, I can trick your web browser into making a request with a legitimate cookie to a different website. That is called CSRF, right? So you can't even trust the requests that are coming in to be legitimate. Sorry, I'm going a little bit fast. Yeah, so you can't trust those to be legitimate. Okay, and then of course, data coming in from web services, data coming in from databases, even internal databases, cannot be trusted. Because very frequently, you will have many different web applications sending data to a single database. So you have no idea if attacks came in some different way. All right, so far so good. So in this boot camp, I only have 90 minutes. This boot camp is normally 4 hours long, so we're going to have to condense the material quite a bit. But normally, and we'll see how much we can work through tonight, I actually build a web application and I demonstrate these vulnerabilities. So specifically, vulnerabilities surrounding file downloads. Have you ever, everybody has used a web application where you can download a file, right? That, if it is not done properly, that can open up a huge security hole in your application. So we're going to look at that. Then we'll talk about file uploads. If you've ever used Facebook or some other website, you can upload pictures. You can upload, I guess just pictures, right? Movies. You can upload MP3s. If the uploading functionality on the server side is not done properly, then that can also result in a very large security hole. Okay. We'll also very quickly talk about cross-site scripting. I think most people know about cross-site scripting, but one thing that most developers don't seem to have heard of is DOM XSS. Has anybody in here, is everybody familiar with DOM XSS? Okay, maybe 2 people said yes, right? Everybody else no. So we will talk briefly about DOM XSS, and then we will get into another feature of many modern frameworks called auto-binding. Auto-binding can cause some serious security issues, and this is a problem in Spring and in .NET MVC. Okay? All right, so think of this like a postcard, right? If developers consider just these attacks, the security world would be improved 100 times, okay? So in other words, these are the most common attacks kind of put on one slide. So there are many attacks that the bad guys can do directly against a server: injection, authentication, access control, libraries. Those are all against the server. There is attacks they can do against the data in transit, which are things like stealing cookies, guessing cookies, reusing cookies. And then there are attacks that the bad guys can do against the users of your web application. So they don't necessarily have to attack you. They can also attack your users. And that would be things like cross-site scripting, CSRF, and clickjacking. Getting back to the ASVS, this is a document that I really hope everybody downloads, right? This is, なんていう日本語では宿題, right? So this is like 宿題です, right? みんなはこのレクチャーの後でみんなはダウンロードしてくれてください, or してください. So this is a really important document because unlike the OWASP Top 10, it actually, you have degrees of security. In other words, every application does not receive the same amount of security. Your public-facing internet applications obviously are deserving of more security than internal applications. So this document allows you to decide what level of security that you wish to apply. And the levels are level 1, opportunistic. So this would block just maybe somebody who's just playing around and wants to see if they can hack into your web application. Standard, which is normal security for most web applications, and then advanced. So if you're defending against governments or you're defending against large criminal organizations, then you want to apply the advanced level of security. And within the ASVS, they actually will, and I'm going to show you throughout this talk, the ASVS, you will see various items that are marked as either opportunistic, level 1, standard, level 2, or advanced, level 3. Okay, so far so good? Good. Now, this is super important. Very, very important, right? The whole concept of secure coding is making sure that for every possible security hole, you have put a corresponding security control. Okay? So for every possible vulnerability, you have the equivalent security control that would block the attack. Make sense? So for example, if there's a possibility of SQL injection, you have a parameterized query that would block that particular attack. So secure coding in a nutshell, secure coding at its heart is figuring out what are the vulnerabilities and then in making sure your code has the proper security controls. All right. So let's get into some basic security issues, and I'm going to throw some videos up. So I want to show you very quickly using .NET as an example. Okay, so hopefully this won't go too quickly, but in this example, I'm going to make a brand new .NET web application. And out of the box, so when you start up, if you're a developer and you want to build a .NET web application, you essentially walk through these steps, which I'm about to show you. I'm going to use MVC, which is a very popular model view controller framework. And without doing anything, no code, already I have a partially built web application. So I've done no coding. All I did was start a new project, and you can see that Microsoft generates for you a half-built web application. Now, this is brand new. This is the code that Microsoft is giving you. Does this have security problems already? Yes, right. Unfortunately, it does. A little bit. So right from the beginning, you can see I have various pages that are already set up, but it has a register link and a login link. Now, registration is creating a brand new account. So these are minor issues. These are small issues, but I want to show you. I will make an account called jerry@owasp.org, which is my email address, and I will register that. Now, first of all, I try to put in the password, right? I don't know what the most popular password is in Japan, but in America, the most popular password is the word password, right? People love that password. It does not accept the word password as a password. It tells me I must have one letter, one digit, and one special character. So the second most popular password is this. Because it is exactly the same thing, except with a capital P, with a number, and with a symbol. Right. So people, みんなはちょっと、users はちょっと怠け者ですね。So 一番大切の簡単なパスワードを作る I don't know. They use the easiest possible password. So if I put in that password, okay this, right? So already this is a little bit of a problem. It's a little bit of a problem because most web applications do not do this, but you should do this. Your application should block common passwords. In other words, you should have a blacklist of passwords that should not be allowed on a system. Okay? Easy security point, but this is something that should be done. Now, here's the second thing I'll show you. I already made an account called Jerry@owasp.org. When I try to make a second account, Jerry@owasp.org, it tells me, no, this name is already taken. Is that a security problem? Yes. Yes. Yes, because now I can try things like admin at, right, yourcompany.com. I can try administrator at. I can slowly figure out what names are legitimate and what names are not legitimate. And if I'm going to attack your website, I need to know, if I want to log in as somebody else, I need their username and password, and now I'm halfway there. So this is a vulnerability. This is a security hole. It's not a huge security hole. It's a small security hole, but it's still a problem. And in English, we call this username harvesting. Username harvesting. And it's mentioned in the ASVS. Yes. Okay, so that's the first example. Now, remember I told you that security is always about a problem, or a security hole, and then a security control. So a security hole and a security control. This is a pretty good security control for blocking common passwords. Remember, we all agreed that certain passwords should not be allowed. Certain passwords should be prohibited. Like, wrong way. Like this password should not be allowed, right? So this tool, which is put out by Dropbox, you can use it as an example. Don't have to copy the code, but you can use it as an example. It has something like 10,000 passwords that should not be used. So immediately, if you take this code as an example and use it, then you are already helping to fix the problem we discussed earlier, which is allowing common passwords to be used. Okay? So this is an example of a problem and a security control, right? Security hole, security control. Okay, and then we had this problem as well, where it displayed the name was already taken. This is from the ASVS. So if you see at the bottom there, this thing, that is from the ASVS. Point 2.18 says verify that username enumeration is not possible. And that would be for all 3 levels of security. Remember we talked about the 3 levels of security: opportunistic, standard, and advanced. In all 3 of them, you should not allow attackers, you should not allow criminals to figure out what usernames are already taken and which ones are not. All right, so far so good. We're going to move on to the next example, right? So now that we've already discussed some very basic things, let's get into file download as a possibility, as a problem. Now, yes, sir, question.
Sorry for the interruption.
Oh yeah, no problem.
In the last example,
Yes.
what is the mitigation for the
Good question. Very good question. Yeah, the question was, with the last example, how do you avoid showing which username is already taken, right? The way that I like to do it is if you come to my website and you want to make a new account, all I ask you for is your email address. Then I email you instructions that will give you a link for the next few steps. If the name is already taken, I send you an email that says, welcome back, right? You forgot, you already have an account. If you're a brand new user, you have an email that says, welcome. Click this link to finish your account. So the users in the user interface, all they ever see is thank you when they supply their email address, and then I send the email for finishing up the account.
Because I know that most companies not using that mitigation.
Yep, that's true.
Most of them is vulnerable to this.
Most of them is vulnerable to this. This is not the worst vulnerability, right? So out of all the vulnerabilities in the world, this one is like not so bad. But if you want, depending on the security level of your application, you might decide this is the way to go, right? If you have an e-commerce application, maybe it's not important, right? If you have a portal login for your corporate customers, then maybe this is a good thing to have. It all depends on the level of security for your application. Good. Question back in the back.
Continuing on what you said, the solution that you gave,
Yes?
you said you would personally like to use his email address as his username to avoid kind of a security hole.
Uh-huh.
So, for example, you have, if somebody has a Google Mail account,
Yep.
so I can use my Google account in 2 ways. I can say username at gmail.com
Yep.
And username at googlemail.com.
Mm-hmm.
So how do you avoid that kind of problem?
Okay, so you're saying,
An e-commerce application, I can use my mail account twice
right.
and kind of hacking or,
Okay, great point, great point. So the question is, essentially, how do you prevent people from creating multiple accounts? Is that the question? Google has 2 different ways to put in your email address, so how do you stop one person from entering in both addresses, correct? How is that, just out of curiosity, what do you think the security implication of doing that is? That I can make 2 accounts with one person?
you can use your same account to do something twice.
You can use the same account to do something twice. But I could also just open up 2 different Gmail accounts, right? And do the same thing? So I'm not sure if it's a really bad vulnerability. Very related though is one thing that most websites do not do is they should prevent you from having multiple sessions of the same user. So in other words, I shouldn't be able to have 10 computers open, log in as Jerry at owasp.org on all 10. The website should say, wait a minute, why is this guy logged in on 10 different computers, right? And those types of problems were all things that you would fix on the back-end code side. But from the one that you talked about, yeah, I mean, it's not, you're saying what if a user uses the same email address to create 2 different accounts? I don't know that that would be a major vulnerability depending on the circumstances of your web app. Okay. Make sense? Cool. Now, question for the people who are developers in the room. Has anybody used Stack Overflow before? 1, 2, oh, okay, now everybody, right? Okay, so you've used Stack Overflow.
So recently, Japanese version released.
Oh, the Japanese version of Stack Overflow released. Fantastic. Question. the code that you find on Stack Overflow, is it secure or not secure? What do you think? Well, that's a good question. Do you trust your own ability to do a security review of the code? Every example that I'm going to show you, I copied and pasted directly out of Stack Overflow. So I went to Stack Overflow and I typed in how to do file downloads in .NET. And that's the code that I used here. How to do file uploads in .NET. That's the code that I used here. In other words, if you are going to these websites, and I'm not e.g. making like Stack Overflow, right? I'm not trying to just pick on Stack Overflow. I'm saying any website where you go and copy and paste the code directly could have some major security problems. And that's what I will show you here. And what makes this scary is that most of the time I chose the very top hit. So if I type in filedownload.net, the top hit is the one that I used. And these all had security problems in them. Now, one more thing. When I went to Stack Overflow and I typed in ASP.NET MVC, 103,000 questions. When I typed in ASP.NET MVC security, I got 1,620 questions. So that means that only 1.6% of the questions have anything to do with security, which is kind of sad, right? It's kind of sad. It means most people are not searching for security. Only 1.6%. Most people are searching for functionality. And that is sad because you can open any book and learn how to code functionality, but it's very hard to learn security, and nobody's even searching for it. All right, and then this is also very kind of sad that this is how many people are searching for .NET in general, and this is how many people are searching for cross-site scripting in general, and SQL injection in general, meaning that you've got all these developers searching for how to build a web application, but almost nobody searching for how to secure the application. Okay, so I'm going to show you another example, and it's going to have to do with access control. Is everybody familiar with access control? What that means? How do you block users from accessing resources they should not access? Okay? So in the ASVS, there are three major things that I'm going to demonstrate in the example. Verify the users can only access secure functions, verify only access secure URLs, and verify only access secure data files. It's the same sentence, just repeated 3 times with slightly different objects. Okay. All right, so what I want to show you is with the application, remember, I haven't done any code to this application. This is how it exists, right, when Microsoft creates it for you. There is a concept of routing. When you go to a URL and you type in www.yourcompany.co.jp / and then you add in the rest of the URL, it will go to this routing controller. And the routing controller will decide what code to execute on the back end. Okay? Now, out of the box, it's a little bit too permissive. So right when you create this thing, the code that Microsoft puts in, it's a little bit too open. Okay? So I'll give you an example. We find this all the time when we do. Oh, sorry about that. Thank you. We see this type of vulnerability a lot where a developer will add in to the controller. So again, if you're not a developer, I apologize. These are programming specific terms. But within this thing called the controller, if a developer adds a method and they put sensitive information into this, this is something that developers do all the time. They'll make a method, they'll put, for testing purposes, they'll put some data into it, and they don't realize that without doing anything else, this function can be called by just simply typing in the name of the function up in the URL. Which means if a developer is not even thinking, they're just putting a test method in, by default, attackers can reach that code and execute it because of the way that the .NET MVC routing algorithm works. Daijoubu? I told you this was advanced stuff, okay? So I'm just putting together this little sensitive piece of data. I'm not doing anything else. I'm just calling a method called info. It's going to return back some important information about the server, things that you would never want to be made public. If I run the program, run it, even though for what I just wrote, there's no links, there's no change, no links, nothing. If I go to the URL and I type in home/info, I just executed that method. So what makes this dangerous is if anybody in the controller makes a public method of any type, it can be invoked by simply typing in the name up in the URL. Okay. Why did I demonstrate this? Because developers unfortunately make this mistake all the time. They don't realize that when you download this framework and start using it, there's all these assumptions that the framework makes. And that if you're not certain on what you're doing, you can open up a big security hole. All right. So that example actually violated these security requirements. So if you were doing an evaluation of this application, you would be able to see that that sensitive function was accessed without permission. All right. So that was the routing demo. Let's see here. Okay. So the next example I'm going to show you is path traversal. Has anybody in here heard of path traversal? Okay, my guys up in the front, good. But everybody else, right? These are my buddies here. But everybody else knows. So path traversal is a very interesting vulnerability. You've gone to websites where you can download files, right? Download images, download music, download PDFs, etc. But if it's not coded properly, the attacker can essentially hack your web application to download any file whatsoever. So let's jump into it. Okay, so this is the code that I got from Stack Overflow. I just changed just those little headers at the top. I've added no other code. Okay? So I'm going to go into the bootcamp, what they call controller. I'm going to add the bootcamp controller. I'm doing this all from scratch. So I'll call this bootcamp controller. And I will make a method called download. Now the code that's going to go into download was directly from Stack Overflow. So first of all, I'm just going to test this and make sure that it works. I wanted to show every single step. And this is just basically just a test to make sure that everything works. I'm going to make a form. And if you're not familiar with .NET, this is how you actually create a little drop-down box. And I'll make it'll say pick a file, and then I will add in the items to download. Now, what's important to note here is I'm going to make a list that will have, I'll say list.add. I'll go ahead and add in two different file names. This is exactly how developers do this. Bootstrap, and I'll call bootstrap.css. I'll copy and paste that, and I'll allow you to download bootstrap.min.css. So these are two files that are already in here that I will allow people to download. Now, there's already a problem. If you're a developer, hopefully you recognize that the fact that I'm putting these file names in, and I'm going to take those file names and then search for them on the server side is a major problem. This problem we find it in web applications all the time. All the time. This in English is called direct object reference. And it is in the OWASP top 10. It is in the ASVS, direct object reference. So if I run this, you can see I have a drop-down list and everything worked. Now, I write the code that says, okay, when somebody picks a file and they hit submit, this is what's going to be called. So this is going to be the code that will actually allow you to download the file. Right now I'm just testing it. You selected file name. So you can see when I run this, I pick Bootstrap. It says you picked Bootstrap. It says you picked bootstrap.min.css. So clearly, depending on which file they pick, that message then goes back to this particular part of the code. Now this is the part that was from Stack Overflow. I'll simply take the file name that they sent me. I will actually then I'll use server.mappath to find it on the file system, and then I'll simply return the contents of that file. Okay? So this is exactly what Stack Overflow told me to do. Get the file name, combine it, return it. Now, if I pick Bootstrap, I see Bootstrap. If I pick the minimized version, I see the minimized version. Now, this is usually where most developers will say, hey, this works, right? Developers will get it to this point, say, it's good, ship it, right? Put it out onto the internet, this thing is good enough. But the problem is what? Remember what we talked about before? Ichiban taisetsu no pointo? Don't trust, right? Don't trust data, right? So external data we cannot trust. So, is this video over? No, not yet. Okay, so I'm going to use a tool now called Zap. Has anybody heard of Zap? Yeah. Good, a few people. Zap is a tool put out by OWASP that is essentially used by hackers and security people to do security. So what I did was I'm going to set this up so that I can intercept the request. So I go to Firefox over here and I will type in manual proxy configuration and I will say OK. So now all of my requests are going to go through Zap. So any post requests or any get requests will go through. So I'll go to Zap and you can see that already all the requests are coming through Zap, which is a good thing. It's going to allow it to, I'm going to be able to see now when this file is sent over. So if I pick Bootstrap, I hit download, Zap picked it up. So what I'll do is I'll set this to block future requests. I click on download and Zap is telling me, hey, they just made the request for bootstrap.css. I'm going to change this to /web.config, which is a configuration file that should not be accessible. When I click on OK, you can see that this is now a secret file that should not be accessed. This is a file that contains configuration data. This is a file that contains passwords and things like that. And you can see very easily, by manipulating one parameter, I was able to grab this sensitive file. Make sense to everybody? OK. The ASVS does deal with this, like I told you. In the ASVS, it tells you that you need to verify that only secured URLs. Oh, no, I'm sorry. We already talked about those three. This one. Verify that access controls are enforced on the server side. So we allowed on the client side those file names to be sent from the HTML to our web server. However, we should have done some checking on the server side as well, which is what Stack Overflow didn't mention, the developer didn't do, and it wound up allowing us to get hacked. Okay. Makes sense to everybody? Any questions? Okay. A few years ago, by the way, there was one very large Japanese company that was being hacked over and over and over again. One of the hacks was exactly this hack, right? So they were able to steal files by doing a file traversal attack. All right. Any questions? Everybody's kind of quiet. Mina wakaru no? Mina wakarimasu ka? Yes.
Actually, I guess
Okay.
it's a little bit easy.
Oh, okay. Well, I'll make it more difficult. Sorry. All right. Everybody's bored. All right. So let's talk about exploiting file upload. How much time do we have, by the way, left?
So now 40 minutes.
40?
Yes.
Okay, cool. All right, so let's talk about file uploads. So file uploads also pose a significant problem, and honestly, you know, I'm going to pick on your question a little bit. People tell me all the time, oh yeah, okay, this is, you know, this is not that complicated sometimes or whatever, but we find them over and over and over again. So in the company that I work for, we review websites, thousands of websites every single day, and we find these vulnerabilities everywhere. So there's a discrepancy, there's a problem. Some people say they know how to block these problems, but yet we're still able to hack these companies over and over again. So it is a dilemma. All right, so let's move on to file uploads. Oops. Hopefully everybody, if you have a web application that allows files to be uploaded, these are the points that the ASVS document makes, 16.7, 16.8, and 16.9. Verify the files that are obtained through untrusted sources or sources are stored outside the web root. I almost never see that done. Verify that web or application server is configured by default to deny access. That almost never happens. And then verify the application code does not execute uploaded data obtained from untrusted sources. This point right here, 16.9, is the one that I'm going to violate right now. So let's bring this up. Again, this is code that I got directly out of Stack Overflow. One second. Okay. So, oh, wait a minute, this is not it. This one. Okay, so I'm going to add some file upload functionality now. And I will go down here and I'm going to add, I already have my download functionality. I'll now add my upload functionality. I'm going to use this method, this attribute called HTTP GET. That means when somebody uses the GET method, it's going to call this version of upload. And I'm simply going to return a view. So I'll go over here and now have to create that particular view. And I'll call that view simply upload. And what I'll do inside of the upload is give the user some HTML so they can upload a file. So let me make this go a little bit faster. So I'll do what I did before. I'll use the HTML helpers within ASP.NET MVC. And I'm going to create basically a form. And this is the same code that everybody uses in order to upload files. And I'll just set the encoding type to be multi-part form data. And I'll just simply call this control upload file. That's important to note because it's actually linked with a variable on the back end as well, upload file. Now I'll just put a submit button and that's it. If I run this code, you can see that that's what you get. You get a little button, you can click and you can upload files. So now that we've got that working, let's add the code on the back end that will accept these uploaded files. So the HTTP post version of this method, I will basically say, okay, it's going to be accepting the uploaded file. And this is exactly out of Stack Overflow. This was all the security that the Stack Overflow example had. Okay, that was it. If the uploaded file does not equal null and the uploaded file.content length is greater than 0. So that's the only validation that was put in there. Not great. Okay, so down here below, if it doesn't meet these criteria, I'll say return could not save the file. If it does meet this criteria, I will save the file. So var file name is equal to path.getFileName, uploaded file.filename, again, exactly out of what Stack Overflow told me to do. Path.combined, server.mapPath, ampersand tilde uploads. So I'm going to put it in the uploads directory right here. And then I'll sit with the file name. And then I'll save that as the path and file name. And then I'll return the message, file saved, file name. OK, so since everybody knows all this, what's the problem? What is the security hole here? 今のセキュリティホールは何ですか？大丈夫ですか？このコードは 100% スタックオーバーフローから大丈夫？セキュリティホールがありますか？ここには。There is. There's a huge security hole. What do you absolutely need to check? There are several problems here. There's many problems. Okay. Number one, we don't check the size of the upload file. So somebody could upload huge files and basically we run out of disk space. Right? That's one problem. What's another problem?
You cannot upload any type of file and then collate from the browser.
Okay. Yeah, so the comment is you can upload any type of file. So what kind of file would be the worst case scenario? Which file would be the worst one to upload here?
Some scripts that you interpreted.
A script? So what kind of script? You're on the right track. No, you're there. ASP, right. So the problem with this code is that anybody can upload server-side code that will then be executed if it is in a directory that can be accessible. And by default, the way that we have this configured, it's accessible. So let's look at the worst case scenario now that, well, first of all, let's make sure this all works. There we go. It'll go to file upload. And we'll just browse and upload a file. I already have a file there called myfile.txt. Click on open, click on upload. It says that it's saved. I can manually navigate to the uploads directory. And you can see that that's the content of the file. It just said hello. OK, that was the end of that little video. So we're going to now jump to the suggestion that was made, which is what's the worst file that you can upload? Well, I went out to the web and I looked for something called a web shell. Has anybody heard of a web shell before? Good. So a few folks. A web shell. Oops. Hang on. I went too fast for that one. So the web shell, you can see it right there, web shell.aspx. So this web shell, what it's going to do is it will give me command line functionality directly by just simply uploading it to the server and then executing it. Now, this is a vulnerability that is very common, unfortunately. And it actually gives the attacker complete control over your server. So if I upload this file, and again, you can just go and type in C# web shell. You'll find them all over the web. Everywhere. This is what it does, right? I can go now in here in the shell. I can type in a command line program, dir, click execute, and it will execute the directory listing, right? So this can be the problem if you're not secure in the way that you allow file uploads, if you're not validating file uploads. And then, of course, I've got access to all of these different directories and files and everything else. Essentially, the attacker has control over your web server at this point. Okay. Make sense to everybody? Okay. So there's not one security control. There's many security controls that you would have to add to that source code to make it secure, right? You'd want to check extension type. You'd want to check size. In addition to extension type, there's also vulnerabilities that not a lot of people are sometimes aware of. So for example, this might get a little bit too weird, but Does anybody know in HTTP what %00 stands for? What is %00? It's the null byte character. The null byte character is used for what in the C programming language? Terminate the string. Terminate the string. So depending on the server, sometimes I can send a file like .jpg, but before the .jpg, I put in %00, and that part will fall away. In other words, I can then potentially send a .aspx file to a web server, and the extension is dropped. Right. Okay. So that gets a little bit more of a interesting thing. And the point is, there's a lot of different security considerations when you're doing tricky stuff like allowing file uploads. Okay. So we've done that. We have three more examples to go. So we'll look very quickly at cross-site scripting, and then we'll look at DOM-based XSS. So first of all, many modern frameworks do something called auto-encoding. So auto-encoding means that automatically untrusted user input is encoded to block cross-site scripting. In .NET Web Forms, which was the framework used before MVC, you never knew if the web control would encode or not. In other words, there's thousands of different methods in web controls, and 50% of them auto-encoded and 50% didn't. And there was really no way to know which ones encoded and which ones didn't. But this is the way you block cross-site scripting, is encoding, and some of the controls auto-encode. In Razor, which is used by .NET MVC, it auto-HTML encodes. So if you use these methods like HTML raw along with allow HTML, you will actually turn off the XSS protection in .NET MVC. Okay, so let's take a very quick look at a cross-site scripting demo. So let's go ahead and just call this thing XSS. And I'm going to just very simply, let me speed this video up. I'm just going to display some setting here. So I'll go ahead and say, here's your autoplay setting, request autoplay. .NET by default, so hang on, let me back up for 1 second. All right, for those of you who are developers, if I say @request autoplay, that's going to look at the URL, find a attribute or find a variable called autoplay, and that's going to be displayed on the page. Is this cross-site scripting? If I'm taking a value from the URL and displaying it on the page, is that a security problem? In this case, no, because Razor, which is what I'm using here, which is this format for displaying values, Razor will auto-encode the problem. So take a look. I will type this in. If I go ahead and I build the project, and in the URL, once it comes up, whoops, hang on a second. If I put in question mark, autoplay is equal to true, or 1, you can see that it shows up on the screen. Autoplay is equal to 1. If I type in autoplay is equal to script alert / script, is this going to execute JavaScript, do you think? Well, where the JavaScript that I entered up there in the URL, will that be displayed on the page down here? Will that execute? Nope. .NET actually will block the cross-site scripting vulnerability. So .NET says, no, 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 you're not allowed to have that up there. However, that doesn't mean that this framework will block 100% of the cross-site scripting attacks. If I type in the script tag, and I have var auto is equal to, and I will do the same exact thing as I did up above, request autoplay. And then I'll put in some basic code. If auto is equal to 1, document.write. So basically, I'm going to display this code within the script tag. And all this code is basically saying, OK, if I receive this variable, turn it on, turn it off, or display the vulnerability. This will not be, you can see it does the same thing. Autoplay is equal to on, autoplay is equal to off. And if I type in my alert 1, I was able to get cross-site scripting to execute through the application, even though you do have this built-in encoder within .NET. Does this make sense to everybody? In other words, .NET cannot protect you from every situation. And this is a situation where the developer made a very large problem. They essentially put untrusted user data directly into a script tag, which is something you never want to do. OK, so if I look at the code, scroll down, you can see that something is happening, like double quotes are being encoded. So if I put in double quotes, in other words, Microsoft will catch and stop the attack if it has double quotes. But if there's no double quotes, it goes right through. Okay? Because only certain characters are being automatically encoded in .NET MVC. Now, what's the important point to this? The important point is a lot of the times these protections don't block every possibility. They only block certain cases of cross-site scripting. Now, in this case, I'm going to fix the problem by putting my single quotes around this. So that's the first way to fix this. And then I'm going to use this HTTP utility.javascript string encode. So Microsoft, in the .NET framework, gives you a library for encoding these types of values. Okay. Now, what's important to note is if you're a Java developer, if you're a .NET developer, if you're a PHP developer, every language and platform is going to have a set of encoders. You have to know and have to use those encoders every time you have a piece of untrusted data that is going to be displayed on the page. So this is the way that you fix this particular problem. You surround it with double quotes, and then you need to use your HTTP utility.javascript string encode. This will block the attack. Hopefully. Let's keep our fingers crossed. Hopefully it will block the attack. We'll try the attack again. Question mark autoplay is equal to 0 alert. I'll do the same thing I did before, and you can see that now it just shows up on the page. It doesn't actually execute. All right. Any questions on this? So what's the takeaway? If you're having user data, untrusted user data displayed onto the screen, you need to make sure that you use the proper encoder. That's pretty much it. Also, this is another minor point, but before the JavaScript would break when I put in the double quotes. Now the JavaScript is actually properly encoded for JavaScript /U0027. All right. Interesting stuff? I don't know. Maybe. Hopefully. It is for me, right? This stuff is, how do you block these attacks is a very worthwhile topic to discuss. OK. So in the ASVS, all the mistakes I just showed you are related to v5.8, 5.10, 5.11, 5.12, and 5.13. So there's various types of injection that can occur. We were looking at 5.8. All input data is canonicalized for downstream decodes or interpreters prior to validation. But then you can see there's all these other different types of injection attacks. OK. We got 2 more examples to go. 2 more. We're going to deal with DOM-based XSS. Who in here has heard of DOM-based XSS? A couple people. OK. Everybody likes this because it's got the cat on it, right? People go crazy for this. All right, so let's look at DOM-based XSS. Now, with DOM-based XSS, the automatic Microsoft encoders will not help you at all. So DOM-based XSS circumvents, it goes around all the built-in controls inside of .NET. So let me show you what this looks like. I'll add a new view, DOM XSS. And I'm not going to put any server-side code. It's just going to be some JavaScript. And I'll say var val is equal to document.url.substring. For those of you who are JavaScript developers, hopefully you can read this code. What DOM-based XSS is, for those of you who don't know, DOM-based XSS is when you have cross-site scripting that does not, well, there's several versions of it, but in this case, it's going to be cross-site scripting where the data never goes back to the server. The data never goes back to the server. This is important because you can't use the built-in encoders that work on the server. So in this case, all the functionality is going to happen on the client side in the HTML. So I'm going to write some JavaScript that says, hey, look for a hashtag, then go ahead and grab the rest of the URL. So if there's a hashtag in there, it's going to grab the rest of the URL, and it's going to simply write that value out. That's all this is going to do. So when I run this, there we go. I'll put a hashtag, I'll put the word test, and you'll see that the word test, hopefully, will appear right there. So in other words, whatever's in the URL, the JavaScript is going to grab it and display it. Now I'm going to add one other problem in my JavaScript. Hopefully everybody knows this is a really bad thing to do. So imagine I have a bunch of other code, and this time I will use eval, right? Yeah, not good. Now when I show this example, many people say, oh, well, everyone knows you should not use eval in this way. But that's not true. Not everybody knows that. And eval is only one of many syncs. A sync is a word that means a function that can have that can cause a security problem. So if untrusted code makes it to a sync, that untrusted code can cause a major security problem. It doesn't have to be major. So in this case, eval is a very obvious sync. We have untrusted data going into that eval statement. Now, there's no way that the .NET framework can prevent you from doing something like this. There's no automatic protections at all that are going to help here. Okay? The only thing that will happen is the browser will still, though, block double quotes, single quotes, and angle brackets. Is everybody aware of that? That certain characters are automatically encoded by the web browser? Hopefully everybody knows that. That doesn't matter. Blocking characters is not an effective way to stop attacks. So in other words, even if I don't have access to like single quote, double quote because of the web browser, I can work around this. So let me go ahead and type in alert window.location, and I hit the button. The JavaScript executes, so this is DOM-based XSS. This means that an attacker can put in any JavaScript they want, create a link, and send it to somebody, which will take over your entire website. I'm sorry, will take over the page, the display of the page. If I use double quotes, though, alert hello, it doesn't work. The double quotes were automatically encoded, in this case, by the web browser. But I can work around this. So let me show you this code. This is just some basic JavaScript that basically I wanted to demonstrate I can display anything on the page even if I don't have double quotes, single quotes, and angle brackets. Can anybody read this code and see what it does? No, probably not. It basically, the point is I don't have double quotes, I don't have single quotes, but I need them for writing JavaScript, but I can recreate them by using something like string.from char code. String.from char code, you put in a number in, and then you get a character out, and then I can recreate all the characters that were taken away. So if I copy that, and I put that up in the URL, hopefully this is more interesting than just an alert box. If I hit the button, you'll see that I can create this window that will pop up, and this cat will be displayed. The point is that I'm able to put on top of the website anything I want. I can basically control the website at that point, even though that there were these anti-XSS encoders built into the web browser. You can easily circumvent these things with just a little bit of extra code. Does this make sense to everybody? Any questions? Yeah, it loops like this forever, right? So you're thinking, does it do something else? No. The way I found this is I went to Google and I typed in most useless JavaScript, and this came up, right? So I use it as an example of the fact that I can get any JavaScript to execute on the page using DOM-based XSS, circumventing or getting around the built-in encoders within the web browser. Makes sense? Okay. We only have one more example to go. It's a very sad situation. But we have one more example to go. By the way, I should mention, the ASVS does not deal with DOM XSS. So that's a problem. You can read the entire ASVS. There is no mention of DOM-based XSS. Okay, so this last example, I'm going to show you, has to do with something called automatic binding. Automatic binding. Some of these newer frameworks, they try to be very helpful. What they will do is they will look for HTML elements that have a certain name, and they will look on the server side to see if objects have the same name, and they will automatically link the two. It's actually a little bit dangerous. Actually, it's very dangerous. The fact is that certain server-side values will automatically be populated depending on their name. So I'll show you an example, and the ASVS does deal with this. It says, hey, if your framework does automatic binding, make sure that the attacker cannot just stick values into server-side values that should be private. This will be the last example. So I'm going to set this up by creating a model. And if you're a developer, hopefully everybody's familiar with what this is. I'll start a brand new class. And I'll just simply, let me make this go a little bit faster. So we'll call this thing public class expense. And within an expense, I'll put public ID, public string description, and then public Boolean is approved, right? Now, this example is based off of a consulting engagement that I did where I found that anybody within a certain company, I won't tell you which company, but any employee could approve their own vacations. Any employee could approve their own raises, right? So all the raises, the salary was in a web application, and there were vulnerabilities where an employee could approve their own raise, right? Give themselves more money. So this is a way that this can happen very easily. In .NET, it's almost too simple to essentially build a database-enabled application. This is all you need to do. This is literally all the code. So I have ID, description, and is approved. And what I'll simply do is .NET will build for me a user interface automatically. So I'm just telling .NET, hey, based on this class, I want you to build a user interface for me. When I run this code, without doing anything else, I can click on auto binding, and I can create new expense, stapler, and I can create a brand new expense. So this is all good so far. Now, whoops. Now, one problem is I don't want employees to be able to approve their own expenses. I want to take that functionality away. So this is what most developers do. Once they realize, oh, whoops, I shouldn't have allowed this is approved, that should not have been displayed to the user, they'll go to the HTML, and they'll simply remove the HTML that creates that part of the user interface. We see this problem pretty frequently. So I go ahead and I remove that in the user interface. Now when I run the program again, and what I'm just removed is the checkbox where they can approve their own expense. So auto binding, and now you can see that although there is stapler, oops, if I go to create new, I cannot auto approve it. I don't have a checkbox to auto approve my own expense. And I'll just type something in their computer, whatever, create. And then when I hover my mouse over there, it doesn't allow me to change it. When I go to edit, there's no way to auto approve it. So at this point, this is where most developers say, okay, ship it, right? It's good enough. I tried to auto approve as a user. I wasn't able to do it. But we're going to pull out Zap again. And this time I'll make an expense. First of all, I'll set Zap up, and I will allow it to intercept requests. I'll go ahead and put in a description like trip to Florida. When I click on create, Zap shows me this is the request. And because of the fact that with .NET, it automatically binds the variable names to the back-end members, I can just literally add in ampersand, auto approve, or is approved, is equal to true. Let that go through. Let that go through. And now you can see, it's hard to see, but the checkbox is there. Whoops. So you can see that although the user was not supposed to be able to self-approve their own expenses, if you knew what the name of the variable was, nothing else, just the name of that variable, because of the fact that it auto binds on the back end, you're able to essentially approve your own expenses, which is not ideal. Make sense to everybody? All right. Cool. Well, that was the last of the little demos. Now, for a checklist, this is all .NET specific. So if you're not a .NET developer, don't worry too much about this. But in .NET, what you have to, in all frameworks, you have to make sure that you turn on the proper security controls. In other words, sometimes these frameworks have security controls and the developers never turn them on. So making sure that the most common security controls are turned on is obviously an important thing. Following best practices. So again, if you're not a .NET developer, don't worry about it, but making sure that you specify in a whitelist manner what verbs can actually be executed. You make sure that access control is set using the authorized keyword here, and then require HTTPS. This is something we didn't discuss, but ensuring that all data is sent securely, and then beware of allow anonymous, which allows anonymous users to access functionality. Now, you don't have to memorize these things like do this and don't do this, but your developers should have their own list of security controls that need to be turned on and things not to do as well. This is a hard, and then one last thing, these are some settings that almost nobody ever sets. Security headers. Browsers, modern browsers have certain security settings by default, but they're not turned on. So cross-site scripting protection, that's the only one that is turned on and people turn it off all the time. You've got X-frame options to block clickjacking, strict transport security to ensure that everything is over HTTPS, and then secure to make sure that cookie flags are not sent in the clear. These things are headers that most websites do not turn on. Like 99.9% of websites don't use them, even though they are available. They are available in the browser. All right, one last thing. .NET also does give you anti-CSRF protection. I didn't do a demo on that, but this is essentially how it's used. For those of you who know CSRF, it's two parts. For every form, you add an anti-forgery token, and then upon every request of form data, you validate that the token was there. That is how CSRF is blocked. And then finally, I love it when websites do these things, but most websites do not. So websites that tell you the last few logins plus IP addresses, I know Google Mail does, but most other websites do not do this. But that is great when you can actually see the last few logins. Email alerts. With my bank, anytime any charge is made whatsoever, I get an email letting me know what happened. I wish more websites did these things. The same with SMS codes. This actually bothers me, but it's good. But I travel around the world quite a bit, so certain websites say, hey, what are you doing in Egypt, right? And then will ask me additional security questions. Okay, so that was just a little list of best practices. And that's it. That is it. So are there any questions? Well, actually, I'm going to hand the mic back over, but thank you all very much. We'll handle questions in just a moment. I appreciate everybody's attention.
So before asking some questions, so we want to thank you very much, Jerry Hoff.
Yeah, thank you.
So actually, he's a small trader.
Uh-oh. Uh-oh. Good.
Some people want to ask something in Japanese.
Ah, okay.
日本語で質問しても大丈夫です。もしあれば。こう言っても質問って返ってこないよねっていう話題が今日小山さんかもしれないので、こういう時用になんかキラーなファシリテーションを発明したいなと思っているところなんですけど。それを丸さんさっき散々楽しんでらっしゃったのでちょっと後回しにしたいと思います。他にありますか？お、いいですね。
Hi, thank you for the presentation. My name is Kevin, and I'm from England actually. Maybe you can tell by my accent.
Yes.
But I was wondering, is there any way to kind of test for these security holes in our application? Maybe particularly using automated testing, such as kind of the Selenium WebDriver per se.
Well, that's a great question. So full disclaimer, I work for a company where that's what we do, right? So the company that I work for, we test at scale web applications. So there's no easy way to do this. You make a great point. This is, when you're looking at a web application that's got maybe 500,000 lines of code, the knowledge that any single problem in there could put the entire web application at risk is a major challenge for most companies. What do? I'll tell you what I did. I used to work, I told you, at a bank where I was also responsible for reviewing hundreds of thousands of lines of code. I thought there's no way human beings can do this. So I actually left and I started a company to build, or I co-founded a company to build static code analysis tools. So that's kind of, 3 or 4 years ago, I started a company that does this. Scans through, looks for vulnerabilities, and then reports it back to developers on a nightly basis. But there's no way that human beings alone can do this. In my opinion, you need some type of automation. Because as you can point out, the slightest removal of some kind of an attribute or some line of code or forgetting to do one thing can open up a huge security hole. So that's the automated way to do it. There are some free scanners as well, but again, the level of security depends on the scanner that you're using. But .NET, I don't know if they still support it, but .NET, Visual Studio.NET used to include something called cat.net. And there was another thing called FXCOP. And so they would go through and look for particular problems in the source code. But again, that's kind of a small range of things that it did look for. The other thing that I would mention is if your company uses quality assurance engineers, training them to do some of these security, to give them the ASVS and actually make that part of the standard set of issues that they look for, that would also be a good thing. And almost no companies do this right now. But working security into the QA process is always a good thing. Does that answer the question?
Yeah, perfectly. Thank you very much.
Cool, thank you.
ツイッターに向かっていらっしゃる皆さん、発言するチャンスですが、シャープOWASP Japan のね、タグで検索するといろいろこう皆さん発言していらっしゃるんですが。
So if there are any questions after the presentation, this is how you can reach me. So on Twitter, it's just @Jerry Hoff. There's my email address. This is the address of the tutorial series. So if you want to see more in-depth vulnerabilities, like these types of demonstrations that I just showed you, they're on YouTube. And then for people who want to know about creating a security program, I wrote multiple articles for Computer World dealing with how to actually run a security program within a company. So that's pretty much it.
じゃあ今日はこれぐらいにしておきましょうか。皆さん今日の、セッションをですね、もう一回見たいと思われますか？Can we record your session?
I think you already did, right?
Yeah.
Okay, so what am I going to do with this?
Okay. So can we provide upload to YouTube?
ストレス。いや、大丈夫です。
では、強制的な許可も取れたことです。皆さん半分で済むように、JO さんどうもありがとうございます。
ありがとうございます。
So, when can we plan for the next half?
初めてはもうちょっと日本語を勉強する。So, 今度は 100% 日本語のセッションをしましょう。2年後。
では私たちも頑張って英語を勉強しましょう。本日はどうもありがとうございました。
ありがとうございます。
あとですね、せっかくの機会なので、プロモーションチームとかですね、あと上野さんからとか、あとその告知したいことが、30秒とか1分とかもしありましたら、松原さん、いかがですか？ちょっと告知一言あるんじゃないでしょうか。今週のプロモーションチームの松村さんです。イエイ。松
村です。
書いてます。
びっくりしてるんですけど、ですね、前回のOWASPナイトでもさせていただいたんですが、デブサミット、デベロッパーズサミットに、OWASP Japan でブースを出展します。プロモーションチームは名前の通りOWASP Japan の、および OWASP の活動の、知名度を上げるために活動してますので、その一環として、今週の木金19、20そうですねに、目黒がガジュ園で、開催されます。
ジョジョ園で
目黒で、開催されますデブサミにブースを出します。デブサミに気がてらブースに寄っていただきたいですし、
写真とか撮ってくれてね。
写真撮ってどんどんアップロードしていただいて、拡散していただいて、あと、皆さんのお知り合い、職場の方にも、そういうブースが出ていることを伝えていただいて、OWASPの知名度拡大に、協力していただけると大変嬉しいです。以上です。
ありがとうございます。大野さん、大丈夫ですか？はい、いつでも読んだら来てくれる上野さんです。マイクもあると思うんです
ですね、OWASP Japan でやってるワーキンググループのセキュリティ要件定義ワーキンググループという私がやってるやつがあるんですけれども、しばらく滞ってたんです。なんで滞ってたかというと、脆弱性診断士っていうものを スキルマップ作りでちょっと残ってたんですけど、そっちが一段落したので、またちょっと再始動をしようと思ってます。で、セキュリティの要件定義をですね、作っていただくのにもしご協力いただける方がいらっしゃいましたら、ぜひワーキンググループに名乗りを上げて、ぜひ俺が日本の要件定義を俺が引っ張っていくぜぐらいの気概で来ていただければ、参加していただけると嬉しいなと。素晴らしいです。はい。
いいですね。
ぜひ。いいですか、皆さん。
もうすでに参加されている方も今日は
参加されている方も結構皆さん手伝っていただいてます。
そうですね。ぜひやっていただきたいと思います。あとはですね、今日紹介されたような ASVS みたいなドキュメントをこの際、ガッとまとめて、ね、日本語にしちゃおうじゃないかみたいな。
そうですね。日本語化っていうのは結構OWASPのドキュメントっていつも英語で残念だなって言われるので、日本語化、このドキュメントからやっていこうっていうのは皆さんが率先して立ち上げていただけると嬉しいです。我々のマンパワーだけじゃ全然足りないので。
そうですね。今テスティングガイドを、翻訳しているチームがこう水面下で、ね、頑張ってるんですけど。
そうですね。かなりここすごいドキュメントですからね。
すごい量がですね。
量が半端ないです。
はい、そうですね。あちらこちらであまり統一性のない努力が払われている。
そうですね。それなんとかまとめて1個のプロジェクトで協力しながらできるといいですね。
そうですね。はい、でも最近OWASPの全体的なポリシーっていうかね、それをもう一度見直す機会があったんですが、ラフコンセンサスベースで進めるっていうポリシーが一つあるんですね。でこれは僕ものすごく我々が学ぶべき姿だと思っていて、誰も文句言う人いませんよね、じゃあやりましょうではなくて、まず進んでみましょうよと。そして出てくる新しい意見は、その都度お聞きしながらどんどん進めていきましょうと。その方法で結果的にですね、この第16回になってしまったわけなんですが、はい、大体お越しになられた方々のですね、延べ人数も3000人になろうとしているという、ね、これはやっぱりまだまだこれからだとは思うんですけれども、いろいろやっていけるといいかなと思っています。あともう一つはですね、日本語訳が出るのを待つっていうのはちょっとなんかもったいないと思うんですよね。
そうですね。
2つあると思うんですよ。英語を読めるようになる努力っていうのと、それを日本語にしてでも、自分たちがやっていることの大事さとかセキュリティの実装レベルを上げていこうっていうような普及啓発的な視点2つあると思っていて、英語を読めるようになったらいいじゃんっていうド S 的な考え方もなくはないんですけども、でもやっぱり英語で一時情報を読まないともう無理ですね、セキュリティ。
そうですね。基本的にはドキュメントの量から質から何まで英語の方がやっぱり多いとは思います。
そうですね。
はい、
どんどん常識も変わってきているし。
はい
はい、ではそういう感じで、本日はですね、これにて解散ということになります。ちょっと運営に関わる方々で、もしちょっと打ち合わせしたいなと思う方は、最後、現状武器などにお付き合いいただきつつですね、それちょっとぐらい時間を使っていただいても大丈夫ですが、この会場は間もなく撤収するということになりますので、忘れ物のないようにお願いします。そしてまたこうした素晴らしい場所をですね、提供していただきました、Gゼロックスさんに再び感謝したいと思います。